Hey there, statisticians. So yesterday what we did is we took data and we put it onto a Cartesian plane. We put our explanatory variable and then our response variable on the y-axis. We plotted those as points. Well, plotting those points is always really fun. It's very interesting, but sometimes we want to use those points to predict an outcome. And what we're going to use, and that's what this video is going to talk about, predicting outcomes from those points. So what we are going to get is we are going to draw a line of a line of best fit through a set of data. And we are going to find what we call a correlation coefficient. A correlation coefficient just says how well our values that we have plugged in relate to that line. How well does this line predict our data? We would love our data to be a -1 or a +1. This relates to the slope of the line. So going down is a negative slope, going up is a positive slope. So if we have a slope of -1, we have a great negative correlation. And if it goes +1, we have a great positive correlation. If we get an R of 0, that means our data has no correlation. So we don't want a 0, we want it on either end. We want a -1 or a +1. So like I said, a positive R is a positive slope. That means as X increases, Y increases. And a negative R tells me the exact opposite. As X increases, Y decreases. The value of R is the same regardless of which variable is the explanatory and which one is the response. So XY is the same as YX. And R will not change if we do different units, because R is a measurement of how close is our data to this line that we are going to use to predict outcomes. That's all that R value is. So if we were to do this formula by hand, we would use this formula where we're going to take our 1 over n-1, where n is the number of data points. Y is the value of each Y value. Of course, Y bar is the mean of the Y values, then the sample deviation. This is how it's found out. But honestly, we're not going to do that. We're going to plug everything into the calculator. And then we would take that data and we could look at this. Do we really want to do this? No, Mr. Gilbertson, of course we don't want to do this. We'd rather use the calculator. That's right, we'd rather use the calculator. But this is how it is done by hand. It's a hot mess. I know some of you have talked to me, I'd rather do it by hand. I need to know how to do it by hand. You don't need to know how to do it by hand. You need to know what it tells us. Now, correlation can be thought of a measure, once again, of how well my data fits to, my line of best fit fits to my data. Okay? However, there are some different elements going on, and this is what this is talking about. So I'll let you pause and read it. We get our random samples because it's based on a random sample. So what are the chances that a random sample of data points indicates a high correlation when, in fact, the population are not so strongly correlated? Okay, so sample is different than row. Row is for the entire population. R is going to be for my sample. Okay, that's what we're talking about. There it is, right there. So sample correlation coefficient is my R. If it's the entire population, it's rho. You didn't know you'd be learning the Greek alphabet in this class, did you? You can join a sorority or a fraternity. What we need to watch out, though, is when we have lurking variables. Lurking variables are when we have a correlation that seems to be a strong value, but what we're looking at doesn't affect each other. For instance, a lurking variable is neither a explanatory nor a response variable. Okay, it's not either one. So like this one, over a period of years. Over a period of years, the population of a certain town increased. It was observed that during this period, the correlation between X, the number of people attending church, the number of people attending church, and Y, the number of people in jail, was a correlation of 0.9. Okay, so does attending church and going to jail, is there a correlation between those two? Even though the data suggests there is 0.9, not really. There's a lurking variable involved here that explains why people going to church and people going to jail has gone up. There's an unknown value going on because traditionally people they don't have anything to do with each other. All right. So I hope that helps you with our definitions today. If you got any issues, make sure, or questions, please come to class with them tomorrow. Love to help you out, Patriots. I'll see you in class. Have a great evening.